So we are live. Okay. So today we will be starting with GenAI completely, generative AI, and also some MLOps projects are there. We will do it parallelly, all those things. So we'll start with a new topic. We'll understand what generative AI is, what LLM model is, what transformer is. Okay, it will be little bit of theoretical. Then we will have hands-on also. We will take the API key and we will do all these things also. Okay. So I'll share my screen. Okay. Okay. So in this Gen AI, what we will be doing? Okay, basically we will be doing hands-on, obviously. Okay, I have a slide for this. We will be doing hands-on where we will build real-time projects. Okay, some real projects I have, industry projects I have. Then of course it is used for future ready also because now we are doing transition to generative AI, which we have to pay a lot of attention to because machine learning, deep learning is now being replaced with transformers completely. I'll explain like what is the entire architecture and how it evolved completely. And all, okay. So then, what all we will be doing? Okay, we will build chatbots in this particular course duration. Then we will have capstone projects. Okay, of course we will do deployment also. Again, MLOps will be using. We will be using Docker. We will do this time in AWS and Fast API. Okay, then RAG, LangChain. We will start with LangChain. Here we will learn LangChain also, Lang graphs also we will check. Not just with LangChain Lang graph, we have Llama index also. These frameworks we will study. Okay, we have Llama index that also will do. Then fourth most important AI agents, agentic AI. Okay, Lang graph again it is used. In the entire module we will be understanding this also. And last MCP. Okay, model context protocol, very important, super important topic. Everybody are talking about MCP nowadays because since the evolution of LLMs and AI is in the market, so integrating that whole thing into one ecosystem is required. For that MCP is required. So first let us briefly discuss about what GenAI is, like what is the history of GenAI, how it evolved, okay, then milestone and all those things. How ChatGPT is trained, what are transformers, okay, these things we will see. It is little bit of theoretical. It's not getting updated. One second. Okay. I'll make it black now so that not be problem to the eyes. So today we will start with generative AI. Okay. See what exactly is Gen AI? Okay, why there is so much of buzz going around in the market? Okay, the answer is simple. So there is one guy. Okay, I call him model. Okay, first what I'll do? Imagine this to be a entity or it may be a magic box, something like this. Simple. Okay, first I have some piece of data. Okay, it might include some internet data or it may be any data as of now. Okay, what I will do, I will use this data, I will teach this model Basically, I'm using the data which I already have, existing data. Okay, as we know, data is a lot in this world today nowadays. So huge data is there. It is in trillions. Okay, before it used to be in GBs and all. Now it is in TBs, petabytes. Okay, data, amount of data, and capacity of data is increased. Okay, so what I will do, I will use this data and I'll train a model. So initially, this guy is dummy; he doesn't know anything. Okay, what I'll do, I'll train the model, teaching all the data. Then I expect this model to generate data. Okay, right from training the model to learn the data to generate data is what generative AI is. Generative is nothing but it is generating new data. And how it is able to generate new data? From the old data from which he has studied. Understanding now? So in that many architectures are there. Okay, many neural network architectural diagrams, many conceptual techniques are there, which is helping this model, okay, to generate the data. So this is what is LLM is. Okay, I'm only talking about text data today. We will focus on text. Let us forget about numbers. Let us forget about data sets, images. Okay, I'll be just talking about text data. Okay, I have whole internet data. I will teach the model. Then model will generate the data for me. Okay, and this magic box is what is called as LLM. LLM stands for large language model. Language model. The reason why I'm calling it large, of course, it is trained on huge data, okay, and language because I'm giving the text data, and model is generating the content. Okay, so in a nutshell, okay, generative AI. Okay, I'll tell you how this evolution came. It is not just generating; it is generating data. Of course, now what type of data it can generate? Okay, this can generate text data. We have already seen, we all use chat gpt. Okay, it is generating text data. It can generate audios also. It can generate images. It can generate videos. Okay, to generate these things, okay, when I talk about images, audios, videos, okay, there is a special branch in GenAI. It is called as GAN stands for generative adversarial network. Very super important concept. Okay, GAN is nothing but it is a branch of GenAI is what we can say. Generative adversarial neural network. Generative adversarial neural network, GAN. Okay, it will generate new images for you. It will generate new audio for you. It will generate new videos for you which never even existed in this world. Okay, so this is something like magic box LLM. Okay, so far we have built only small models, prediction model, classification model. This LLM is like combination of everything. Okay, I will show you the transition how it actually replaces the existing traditional ones. Okay, like I'll make use of textual data itself, and I'll be using text as an example, and I'll exactly show you how this generation is happening. Okay, first let us discuss some of the models we have right now in the market, because having knowledge about LLM is also important. Okay. Okay, so initially we will make use of some of the things. Okay, let's see some OpenAI we know, na? OpenAI models. Let us see what which model will do what. Okay, so first we have GPT. Now GPT-4, we have GPT-5 also now. Okay, obviously we know, again it's a generator. Okay, second, okay, we have something called as DALI. OpenAI's DALI. Okay, DALI is used for generating and editing images. Editing images. Right answer. You can go. Yeah. Keep here and go. Man ಕೊಟ್ಟು. Okay, third one. We have TTS. TTS stands for text to speech. TTS ಅಂತ ಹೇಳ್ತೀವಿ. Okay, TTS. Text to speech. DAL is for image generation. These are OpenAI models. And trust me, GenAI will be a lot of fun. We will do a lot of things. Okay. Then fourth one we have Whisper. Whisper is for convert audio to text. And of course, text to audio.
These are inbuilt models.
Yes, these are models of OpenAI. And all these models are powered by one guy, one engine called as transformers. I'll explain you what this transformer is. Okay. Okay. Now let us see. Suppose tomorrow we want to generate our own LLM, or we want to make use. Of course, will be making use of some third-party LLM and build our own application. So, what are the frameworks we need to know? Okay, please write down frameworks. Frameworks that you need to know. Okay, first is like LangChain. Okay. Second is Llama Index. Okay, so these two frameworks are required, okay, to build our own LLM kind of system. Okay, now along with this we should also have an idea about database. See, when we are developing a full stack project, it may be a ERP system, CRM, we need databases for that. But when we are developing a LLM, when we are using the GenAI concept and all, we need something called as vector database. Vector database. Okay, for vector database, we have ChromaDB. Second, we have Wavelet. Third, we have PyCon.
Sorry, PIN.
Pinecone, Pinecone. Cone. Fourth, we have OpenAI's. Okay, Firis. Okay, these are databases which we have to study for GenAI. Then tomorrow, if we want to build our web app, frameworks for web application, web apps. Okay, we have to know about Streamlit. Second, Cardio. Okay, third one we have Fast API. Fourth one we have Flask. We have already used Flask for ML projects and all. And of course, deployment. Obviously, we have to deploy also. For deployment, we will use cloud services. We can use AWS, we can use Azure, or we can use GCP also. Okay. So this is a brief sketch. Okay. For we have frameworks, we have vector databases, we have frameworks to develop web applications, and we know how to do deployment also. Okay. Of course, this Docker, Kubernetes, everything will come here. So now let us understand about history of GenAI, how it evolved. History of GenAI. Okay. So if I draw a circle, okay. See if this is entire artificial intelligence.
Machine.
Hmm? Sorry.
Inside the artificial machine learning, that
Yes, 100%. Okay. So this is machine learning. This is deep learning, and this is what GenAI is. Okay. This picture will summarize entire AI architecture. Okay. It is powered by ML. It is powered by deep learning. It is powered by GenAI. Okay. Artificial intelligence, everything. Okay. Here we are training the data. Here also we are training the data. Here we are generating the data. GenAI is nothing but we are generating the data here. Okay, so let us see about the history part. Okay, we have an awesome history actually. Blue. Let's see the history part. Okay, how it all began. Okay, first in 1950s to 1960s. See, we feel that AI is new. People are hearing AI, LLM, and all now, but it started in 1950s only. Its research. Okay, after the world war, during the Indian independence, okay, around after independence it all started. Okay, so there was something called as rule based system here. Rule based system. Okay, see, this is little bit theoretical, but having this knowledge is really important. Okay, so this is here now, a scientist invented perceptron. Okay, a small neural network, not a network, a small. Okay. Okay, rule based. Rule based in the sense put only if else conditional statement. Okay, it started here, and they developed something called as perceptron. We know now what perceptron is like. This will be, it will have activation function, deep learnings, that neural architecture I drawn now. That is what perceptron is. Okay, it will have activation function. It started here. Then in 1960s to 1970s, okay, expert learning phase. First was rule based. Now it is like expert system. Started with the expert system. Okay, so here now decision tree was started, mathematical equation started, decision tree took birth here. Decision tree, machine learning's algorithm. Okay, it was during this phase. Third, from 1970s to 1980s, okay, this phase, machine learning, applied machine learning algorithm started. Applied ML algo. Okay, and applied maths, this calculus, probability. Obviously it is powered by maths and science. Whatever technology we are seeing, it is always powered by maths and science. Okay, it may be computer, it may be universe, it may be physics, everything is powered by maths and science. Okay, then 1980s. Okay, here now it is called as the phase of rebirth of AI. Okay, during this phase, okay, ANN started, artificial neural network, deep learnings started. Okay, artificial neural network started, back propagation started. Okay, okay. Then something called as RNN came, recurrent neural network. I'll explain you what this ANN, RNN, GNN is. Okay. Then fifth, they felt like they were not getting much accuracy when they were training the model. Now this was developed already in 1980s. People used to do machine learning and all, but they were not getting good accuracy. Okay, so in 1990, what they did? Okay, they used boosting algorithms. Okay, they use boosting algorithms. ADA boost. Okay, boosting algorithm. LSTM developed here. Long short term memory. Okay, in a nutshell, I'll explain what LSTM is, what RNN, because these words need to be known before learning transformers. Otherwise, we will not understand transformers. Okay. So, next, present. So, 2002 present, this is era of deep learning era. That's why I did not pay much attention to ML, to be frank. Okay, because it is about deep learning. Okay. In 2012, CNN was developed, convolution neural network for image classification. See, if I put NN, NN stands for neural network. That architecture, Gullas will be there connected to neurons. Okay, during deep learning I explained now that one particular. Okay, so CNN image classification, it could differentiate between cat and dog, apple and banana. Okay, image classification it was able to learn ML AI model. Okay, then in 2014, okay, GAN was introduced, generated adversarial neural network. Okay, to generate image, it was generating new images. Okay, discriminator is there, because encoder decoder architecture was already developed. Okay, because of this GAN algorithm came. Okay, next, 2018 was a revolution in the IT industry, complete AI industry. Okay, transformers was introduced. Okay, transformers, this is an architecture. Okay, architecture for LLM. You can write down architecture for LLM. Complete transformers. Okay, this particular architecture changed everything. Trust me, Ram. If this was not come now, we would not have ChatGPT today. Okay, this changed everything. Before, whatever we were using, it was all replaced by transformers. Okay, and in 2017, okay, Google published a paper called as "Attention is what you need." Attention is what all you need.
2017.
Yes. So in this transformer architecture was explained. Google released it actually.
Before only like Google explains.
Yes, Google were doing research from then itself. Then I'll tell you how Chat GPT came and all.
Now recently Google has came up with some other 10x different new achievement, extra times of India, like
Yeah, something.
something related to this one only.
Okay.
New engine they are doing.
Yeah, yeah, yeah. Correct. It was not yesterday.
2 days before or
Yeah. I heard now Transformer is also getting this thing. Yes. 100%. I agree. I remember, correct. I'll research and I'll tell you tomorrow. I forgot that I was telling to sir also. Now transform is also getting replaced. Correct. Okay. So this paper changed everything. Okay, because of this, 2017 they released, and it had explained all the architecture to build an LLM model. Complete architecture was there. Okay, because of this, OpenAI silently did research and released GPT in 2008. Actually, Google was supposed to release. Google delayed. OpenAI inside they were developing. They shocked the world one day. Okay. Actually, Google did the research on transformers and all. These people used it.
Now new browser like they are coming up. Competitor for Chrome.
Chrome, correct. Chat GPTs are this OpenAI is planning that. Yes. See, because of this paper publication, okay, I'll suggest you just have a glance over this paper. It is in the online. Attention is all you need. Okay, here the entire transformer architecture is explained. Then, in 2019, in the month of November, GPT was released. Actually, Google delayed for some reason. Okay, then in 2020, in the month of Feb, okay, Google released BART,
So BERT.
BERT. Uh, uh, Gemini, when GPT came up, BERT was in news. You know that? Remember something like that? In 2019, during COVID times.
Correct.
Okay, Google released BERT LLM model. Okay. Okay, so this was about the history of GenAI. Very beautiful history. Okay, see, we know how this evolution came. First ML came, then decision tree algorithms were developed. Then after 2000s, deep learning started. Okay, deep learning, then came transformer architecture, because it is all about architecture. If we want to build a beautiful house, we need to have a best architecture similar to like that. Okay, so transformer is also architecture to build a beautiful generator, right, which will generate the data. Okay, so GPT came, Bird came, then Gemini. Bird was replaced with Gemini. Okay, Google named it as Gemini. Before we were calling Bird. Okay, then GPT-3 came, GPT-4, now GPT-5. Then Chinese people released DeepSeek. Okay, everything is based on transformers only. Okay, GPT. The full form of GPT is right, generative pre-trained transformer. T stands for transformer. Okay, and all these LLM models are using that transformer itself.
Generated pre-trained.
Pre-trained, pre-trained. Already it is trained. Generative pre-trained transformer. Okay. Now, so now let us see the difference between. Okay, we will just see the difference. Okay, we will see the difference between discriminative, descriptive model, another is generative model. So there are two important things which we need to know. Okay, I'll check whether it is screen is getting shared. Sometimes the screen sharing goes and whatever I have told becomes a waste. Okay, we will use blue only. Blue looks nice, na? Or you want me to use different
No,
color?
no, no.
That's good. Okay. So when it comes to descriptive model, na, please write down. You have this linear regression. We have already used
Yeah.
linear regression. Okay. So in deep learning, we have LSTM. Third, we have CNN. Okay, convolution neural network. See, these algorithms are used only for specific tasks. Used for specific task. Okay, these descriptive model, generative model is used for specific task. Okay, suppose house price prediction, this prediction, that forecasting, this forecasting. Okay, these are called as descriptive models. Whatever we have studied so far. Okay, image classification it may be. Okay, here it cannot generate the data. It can only give the description of the data. Understanding now? So when it comes to generative model, okay, here now what I'll do, I'll give the text, I'll feed it to a model, and it will generate the audio of it. This is what generative models are. These are descriptive models, whatever we have studied so far. Now we are studying about generative models. Okay, here now huge data should be given. See, here small data would be fine. To do prediction, how much data we need now?
Yes,
That's what. Okay. But when we want to generate a new data, here huge data is required. Very huge, vast data. Okay. And we have to use supervised, unsupervised techniques. Unsupervised techniques. Okay. For example, like image to image, text to text, text to image, text to audio, text to video. Okay. These are all generative models. Okay, so this was a difference between descriptive model and generative model. So far we have known only the descriptive model. Now we are going towards generative models. Okay, you are able to understand now?
Yeah.
Okay. So now let us understand about some kind of unstructured data. Okay, unstructured data. Okay, so we have to remember, okay, when I talk about unstructured data, I should remember only images, videos. These are all unstructured data. There's no proper rows and columns and all.
Logs.
Logs. Okay, then images. Basically we will be studying about images and all those things. Okay, so when it comes to images now, okay, you have something called as two important things we need to remember. Okay, one is object detection models. Another is image classification. So two types of models we need to remember. Okay, when it comes to object detection, we have a famous algorithm now called as YOLO. You only look once. YOLO. Okay, YOLO. Now I think YOLO 13 is going on. I think in the market.
You only look once.
Yes, YOLO. We have SSD. We have. Okay, RCNN. We have. Okay, fast RNN. These are all object detection. I'll give an example. Okay, we have heard of Tesla, self-driving car. Okay, how Tesla can identify there is a traffic light there, or there is a pause, there is a no traffic board, or there is a speed limit board? Because of object detection. It is detecting the object and it is understanding what is this. So if I train a model and if I keep my camera here, it can tell this is a laptop. If I show you on you, it can take it is a human face or person, pen, watch. This is what object detection is. For this, we use these models: YOLO, SSD, RCNN, FastCNN. When it comes to classification, do the classification. Okay, I will place 500 note, 1000 note, 2000 note. Sorry, we don't have 1000 note, 2000 note, 10 rupees, 50 rupees. It can classify which note is what. Okay, for this, we have detectrons. Okay, we have VGG. First is VGG, then ResNet, then Inception models. Okay, efficient net is also used. Efficient net. Okay, so these are all models already pre-trained. Okay, so these are all pre-trained models already. These developers have trained it. Now what I'm doing is, suppose I want to train on my custom data. Okay, see, if I take YOLO now, YOLO can identify almost 200 images. It can tell car, bus, bicycle, knife, then person, phone, smartphone. Already, if I import it and if I want to train my own custom model, suppose if I want to YOLO model to identify this is a charger, this is a stylish pen. Okay, then this is a remote. I trained an image. I place it over the trained image. Obviously, I'll take the trained image and I'll do fine tuning. That is called as fine tuning. Okay, I am tuning over the existing model. Okay, on my custom data. Custom in the sense mine. If it wants to detect my face, it has to tell this is Joel. Okay, I will feed my images. I will train my model over the YOLO. I cannot do it from scratch. Scratch will take a lot of time. I'll take the pre-trained model, train the custom model on it. Understand now? So this is what this is also called as transfer learning. Taking the train model. I can build from scratch also. This neural network first we had built now one project in deep learning. This we had activation function, relo, then this thing. That's why we have to keep going and writing the layers. That will take a lot of time. Instead of that, what I'll do, I'll take the pre-trained model. I'll just show my images, and the image is able to classify what is what because it already knows it already has weights and biases. It is see at last it is about weights and biases tuning. Okay, this much tuning, this much tuning. This is for human face. This much tuning, this is for bicycle. If already weights and biases I know, okay, I'm just placing my data. It is tuning once again, and it is giving me output. Okay, this is what when it comes to image, you have one object detection and image classification model. Okay, now so these are all descriptive models which I'm dealing. Okay, classification, this thing, LSTM, CNN. These are all descriptive models. Okay, this was completely replaced with something called as transformers. Okay, so I told something called as transfer learning just now. Transfer learning. Okay. See what happens is in transfer learning, we use previous learning for the future task. Okay, so for must example I'll give you. Okay, transfer learning is nothing but we use previous learning for future tasks. Okay. Simple example would be you directly did not learn bicycle, sorry, you did not learn two wheeler. You started with bicycle. Bicycle knowledge was transferred to
Bike.
bike. Same thing. Same. Okay. From scratch, I cannot do. Okay. LLM pre-trained models I'll take. I will place my custom data and same is used to generate the new data. That is what transfer learning is. You can write down example.
Yeah.
Bicycle knowledge to this thing, motorcycle. Okay. So transfer learning we have seen. So let us see about deep learning a little brief. Okay, we already know ANN. ANN stands for artificial neural network. Then we have CNN. Okay, this is convolution. Okay, this comes under. Okay, CNN comes under this one. Okay, convolution neural network. Simple. Okay, convolution neural network. It is used for images. Okay, then we have something called as RNN, recurrent neural network, used for text or sequence. Okay, sequence or text. Okay. So RNN, okay, recurrent neural network. Okay, so as I know, this is used for images. This is used for text. Okay. Now, since we are, as I told you, I initially told we will be understanding text to understand the transformers. Okay. Now let us understand how RNN works. CNN we know it is for image classification, cat or dog. Same convolution neural networks will be there. Okay, activation function will be there. Then hidden from input layer it goes to hidden layer one, hidden layer two, hidden layer, then output layer cat and dog, it will tell the probability. Okay, this is how CNN works. Coming to RNN, recurrent neural network. Okay, we speak about textual data. For example, I just put I am Joya, and I want to convert this into Hindi or English. Okay, Hindi I'll type. Mein, okay, so I want to build a image. Sorry, text translation model. Okay, so if I use RNN architecture, what RNN will do? RNN will take this word. one word. Okay, it passes to the architecture. There's something called a feedback loop is there, and it generates one output. Okay, next word goes. Okay, next word is generated, joel. Okay, third word goes, and third word is generated. Okay, of course, this generated, we have this deep learning again. It has to pass through these neural networks and
Models
all.
will take care of it.
Yes. The architecture is same, but RNN has something called as feedback loop. One by word by word by word by word is called. Okay. But there was a problem in RNN. Okay. RNN takes only one word at a time. Imagine you have 1000 words. It will take one word, convert, one word. It would have taken a lot. And it forgets the memory behind which words were there. Okay, RNN was not that much popular. Okay, it came in 1967. Later, because of this forgetting issue, okay, memory was less because it is taking only one word. If I ask you to remember one word, will you remember the previous word?
Okay.
No, no. Like suppose you have 100 words.
Okay.
I'm giving
Sentence.
you, yeah, words,
One
sentence.
sentence.
Okay, you are taking one by word and remembering. Can you remember the past third word, fourth word? You will forget. Humans also, RNN also used to forget. Okay, so RNN was replaced by something called as LSTM. LSTM itself stands for long, short term memory. Okay, this guy used to get take sentences, so that previous memory is restored. Okay, that's why it is called long short term memory, because it can remember. Memory is like remembering, right? Okay, so LSTM, what it does, instead of RNN used to take one word, but the previous context was lost because there is one phenomena called as vanishing gradient descent. It comes in deep learning. Okay, will not go in technical depth. Okay, because of that thing, it was forgetting this. LSTM, what it did, LSTM was replaced by RNN. Okay, so it can remember the sentence, so it can understand. See, my name is Joel. I live in Bangalore. I am working in this company, so it remembers my name. So this remembrance was there in long term. Okay, so now after this, now came something called as encoder decoder architecture. LSTM had also some lacunas. Okay, only long sentence it used to remember. Suppose if I want to use remember if I want a LLM model to remember the whole book, I cannot use LSTM now. See, RNN word by word, LSTM sentence, I want it to remember entire book, or else how it will generate. This can remember only a sentence, okay, but not entire book. So this was replaced by encoder decoder, complete encoder and decoder architecture. Okay, so this encoder decoder architecture formed basis for transformers. Encoder decoder architecture formed the basis for transformers. Okay, so if you see the architecture of a transformer, I'll just show you the architecture. Transformer architecture. If I zoom this, can you see something called as encoder decoder? This is what architecture is. So BERT usually works on encoder, and ChatGPT has both the encoder and decoder architecture. So this is the architecture of a transformer. Okay, see, this is encoder, this is decoder. Okay, feed forward neural network. And I'll explain you attention mechanism. It's very easy. It's nothing complicated in this. Okay. So basically, what is a transformer? Okay, transformer is nothing but this is the encoder decoder. It has something called as encoder. Transformer. It has something called as encoder, and it has something called as decoder. So encoder understands input, understands input. Okay, decoder generates output, understands input, generates output. So you saw something called as positional encoding. Okay, please write down first. In this neural network is there. Okay, feed forward neural network is what is there. That architecture is there. It is replaced in the sense this is not completely different architecture. Good neural network is there. Because of that only it is generating. Okay, so in the image now you saw something called as positional encoding, right? Can you see positional encoding? Positional encoding, feed forward, attention. What is this? What is this embeddings and all? What is this feed forward? Okay, let us understand each one line by line. Okay, so first let us understand. So we know what is encoding and decoding. What encoder will do? It will understand input. Whatever we give, obviously if I'm writing a prompt, please explain me what machine learning is. Encoder has to generate, understand what input is. Decoder, what it will do? It will generate. So transformer is nothing but it is a encoder decoder architecture. Okay, it has encoder and it has decoder, but we cannot see it. We can see only the UI part generator. When we give the prompt, we are giving input and output it is decoding. Okay, so we have something called as positional encoding. See what is positional encoding? Obviously, okay, if it has to generate a text, suppose dog bit a man. So this is correct, right? It should not become like man bit a dog. Okay, this is what positional encoding is. Properly encoding has to happen according to position. Okay, it should not change. Okay, I'll show you how this happens. Okay, what is attention and all, we'll explain you. Okay, we are going to understand now LLM. We will exactly see how this chat GPT, Gemini, whatever AI tools are there, it is generating the output. Because in order to build a large language model or generative AI, we need to know these things. Okay, and building AI model is not that difficult, Ram, to be frank. We already have transformer architecture, but why Indians are not able to build? Because of data. We don't have huge internet data. See, Google is theirs only. They have a lot of data. Okay.
Processing
Yes,
GPUs.
we don't have processing ports. We don't have GPU infrastructure. Because to build a large language model, we need huge GPUs. Huge GPUs, because processing has to happen. Na? See, for RNN, it will take one word at a time. If I use RNN architecture, na, it will take 1,000 years to generate an answer. Okay, so LSTM also. If transformer, then obviously parallel processing has to happen. What GPU does? GPU does parallel processing. Okay, it will make sure that the process is running in threads. Okay, suppose if I'm opening desktop application one by one. If I use CPU, no, first desktop open, this will open. It works on queue data structure. Okay, this will open first, then it will close. Again, next it will open, next it will. Parallel processing opens everything at once. So we need computation power. We don't have computation power. That's why we are not able to have our own LLM. But future definitely India is aspiring, progressing. We will have our own LLM model. I think some companies are working on it. It is a proud moment also if we have our own LLM model. Okay.
That
Hmm.
Vizag data center that you building, that Google one, it related to this one only, GPUs and all they want to. building a server.
Data center for cloud is different.
Yeah, cloud.
Cloud, yeah, but when I talk about building the LLM model, we need to have extensive, huge one is huge internet data and huge GPUs, only GPUs. Okay, they're like hypervisor, everything that is like cloud providers. There also we can take GPUs, but it is like we have to buy it from others. But here extensively we need to use GPUs to train our model, and of course we cannot use cloud GPUs to train our model because cost will be very high. Per hour only they are going to charge huge amount of money. If we have home ground GPUs, then it becomes easy. Can train our model and can do this. Okay. So that's what. Okay. Now let us understand. We saw positional encoding. Let us understand how exactly the transformer architecture works. Okay. So imagine you have something called as, okay. First, let me draw this. This is my magic box. Okay. There is a human text. Okay. There is a human text. Okay. I'll just ask what is ML. Okay, so it goes and passes through this LLM. Okay, it has inbuilt, encoder decoder architecture, self attention is there, then feed forward neural network is there, positional encoding is there. Okay, and it predicts the next word. Okay, so this entire goes into this one. Okay, first one, then you will get some output based on the architecture. Okay, then it will start giving answer. A machine. Okay, now this forms an input, goes there, predicts the next word. Machine learning. Then this goes as an input, it predicts the next word is. Then this is goes into LLM, it predicts the next word. Okay, branch. Okay, this goes as an input, it predicts the next word of AI. Like this generation will happen. Okay, like now let us see how exactly. Okay, I'll give one more example. Okay, Paris. Okay, Paris is a city in dash. So this is the input. Obviously, I have my magic box. So I'll use some different. Okay, this is my LLM magic box. Okay, so it will predict the next word. Okay, how it will predict? It will give probabilities. Okay, it will give France 17%. Okay, and 12%. Okay, the 9%, which 5%, something like this. So based on this, with the highest probability, it will be words will be given. Then this goes as an input to the next. This goes as an input to the next. This is how the LLM works. And of course, this magic box has what all? It has encoder, decoder. It has feed forward neural network. It has positional encoding. Understanding now? Okay, now let us go little bit in depth. Now let us open the magic box and see how it is able to generate the tech content. Okay, this much you are able to understand. It is all predicting the next word, next word, next word. See, when you give the prompt, na, that circle color goes. This is how the content is getting generated, and how it knows. We will see that now. Okay, okay. Now let us see. First, let us understand how this LLM was trained. Okay, let's understand. Because we are talking about LLM, let us see how it was trained, how this GPTs, this Google, OpenAI trained LLM model. Okay, first what they did, they fed huge data, internet data. I don't know from how where they got internet data because I'm on YouTube. Tomorrow there might be problem. Okay, so I don't know how internet data. Maybe they did web scraping. Who knows? Okay, or Google is there itself. They'll get data easily. Okay. Second, this was step one. Step first. What is second? Second step. Okay, they trained using huge text they gave. Okay, to generate the next word, now I cannot give small data. I have to give huge data, huge in the sense huge. If similarly, if I want to train a human, it will take me 10,000 years. But this is model machine. Okay, I can train it. Okay, they gave huge data by Clo. Okay, this is second. Okay, in second step, they use something called as RLHF. Okay, RLHF stands for learning, reinforcement learning with human feedback. Reinforcement learning with human. I spoke about reinforcement learning before itself, like giving awards. Okay, when it is generating good content, give award. Yes, this thumbs up, thumbs down. Okay, because of that, model is able to know. Okay, it has algorithms. Okay, when it comes to RLHF, reinforcement learning, there are three algorithms. Deep Q is there, SARSA is there. Okay, these are algorithms which will understand this learning process. Okay, algorithms are there. Okay, third, okay, since if I had used RNN, it would have taken word by word and it would have forgot the context on what I'm generating. It would have not known. Okay, since it is using whole entire thing and learning, so it is generating the good this thing. Okay, feedback. Now let us completely understand how to train a LLM model. Okay, now this is how it works. This was how it was trained. Now let us understand the process. Let us understand the process. Okay, first I'll give a sentence. Okay, cat sat on the mat. Okay, this is my sentence example. Cat sat on the mat. Okay, now let us see exactly what happens. Okay, so first is like it breaks down this sentence into tokens. First is tokenization. Breaking sentence into tokens. Okay, so cat becomes one word, sat becomes one, on the mat. Okay, these are all broken into tokens. Okay, second, see, this is for text. If I'm passing image, pixels. Okay, images are broken into pixels. Okay, voice also, voice will have frequencies. These are broken into, they are SI units, they are basic units. Okay, second, okay, you have something called as vector embeddings. Okay, so what are these vector embeddings? I discussed when I was teaching this enemy recommendation. Okay, so I'll take cat example. Okay, I'll take cat. Okay, there are some 127 feature embeddings. Okay, this cat will be mapped with the number minus plus 0.5 minus something 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 based on the features. So every word gets its own embeddings. Okay, some 8.5 plus minus some based on some features. Okay, if it is animal, it will be plus 9. Near to be 1, na? Cat is an animal. Okay, so this sentence is broken into feature embeddings. So that is also called as vector embeddings. So we have to store these embeddings when it comes to RAG. retrieval augmented generation. That's why we have databases. I just explained about chroma db and all those things. So these embeddings has to be saved. This number is important for me. I should not lose this number. Okay, tomorrow if I'm generating a movie recommendation also, these embeddings are important. Dot product of two, if there is similarity, then two people are having same interest. Okay, vector dot product of two embeddings is what I'll get similarity. If it is near to one, that means they like the content. If I also like, you also like. If it is near to zero, that means we don't like. So a model will not recommend that movie to us. Okay, these embeddings plays a very important role in the field of machine learning, AI, deep learning. Okay, and we have to save these embeddings. We use vector db, chroma db, we have farsis, we have, okay, all this pinecone. Okay, I have worked on pinecone also. Okay, we have to store these embeddings in the database. Okay, I'll explain when we learn racks and all, we will do it. So vector embeddings are there. Fine. Then of course on will have its own. Then the mat, so it will have its own numbers. On, because model cannot understand English, model cannot understand word, model can only understand numbers. So these words, individual words, are broken down into embeddings. Okay, this is called as vector embeddings. Okay. Now if these words are similar, they get aligned. See, if I draw this in a three-dimensional plot. Okay. Cat sat on the mat, okay, with dog, something like this. Okay, so dog, cat, they are like neighbors here in the three-dimensional, n-dimensional space. Okay, they become the neighbors because they both belong to animal group, something like this. Okay, so this thing. Now these words, third. Okay, so first is what? Text is broken down. Okay, then vector embeddings. Okay, third concept is third concept is attention mechanism. Attention mechanism. Okay, so what is this attention mechanism? If you see the architecture of this, I can copy it. Copy. I can't paste here, I think. Ah, nice. So this was nice. Okay. So, okay. So can you see there is something called as attention here?
Yeah.
Okay, attention mechanism is there. Okay, attention. What is this attention? Okay, this is very important. This will map the relation of one word with another. I mean, it will make words to talk to each other. Talk to each other. Okay. Okay, this is fine now. Okay. What it does, it makes words to talk to each other. Because, so for example, I'll take a machine. Sorry, I'll use some a machine learning model. This is example A. So second example is a fashion model. Model is same. But can you see here the context is different, here the context is different. If I had used RNN, it would have got confused. Okay. So using attention mechanism, I can map the relation with this. This is a machine learning model. Here it is a fashion model. Simple as that. Okay, this is what attention mechanism is. This attention mechanism was also proposed in transformer architecture. Okay, because of this, it can understand the relationship between a word. That's why it can give accurate answers. LLM, if you are giving, it is not giving wrong answers. It is giving accurate answers. Bank is different, river bank is different, and bank account is different. It can know the relation because here now, when it comes to machine learning model, here the vectors are aligned in the dimensional space. If it is machine model is here, for fashion it may be somewhere here. Okay, so this is how the attention mechanism is. Okay, then we have something called as, okay, This now we have these vector embeddings because of passing through attention layer. Again, the values are updated according to the relation. Cat sat. Okay, almost the relation is near. It is not very far. Okay, because of this attention mechanism, the updation is happening again. Okay, now once again, see updation of vector embeddings. Okay, then fifth. Okay, what is fifth? Passing through neural network. Okay, now these values are passed through feed forward neural network. Can you see here feed forward this softmax activation
Yeah.
percent and output probabilities? It gives number. France is a city in dash, so it gives some words, and based on the highest probability that word gets mapped. Okay, so first once again we will see. Okay, words, sorry, a sentence is broken into tokens. These tokens gets mapped with the vector embeddings. These vector embeddings pass to attention mechanism where the relation is mapped with each other. Again, the weights are updated. Sorry, these numbers are updated. These numbers are then passed to feed forward neural network. Neural network in the sense this 128, whatever embeddings are there, 128, this thing. Okay, so it will predict different. When I pass it to the model, okay, this deep learning model now, okay, I get probabilities of different words, and with the highest probability the next word is predicted, then entire word goes as an input. Same thing, vector embeddings mapped with the attention, output is given this way. Because we are using GPU, it becomes faster. If we were used CPU na, it would have become one word, then after 10 minutes another word. After this process has to happen now. See, LLM we know, like non-technical person can understand what is this, it is like chatting. But as a technical people, we should know how this entire architecture works. GPTs. Okay, so since LLM is already trained, as I told you, human feedback, so it knows weights and biases already. Biases. It is just passing through this feed forward neural network and is generating. If it has to build from scratch, it would have taken days, months, years. Since weights and biases it knows. Okay, that's why it is able to generate the new content. Okay, have you heard that this model has 125 billion parameters? This model Llama has 45 billion parameters. This has this much. Have you heard of it? Billion parameters.
I think you have told us.
Yeah. See, if I go to Llama, na, see here now all models you will get deep learning models. Sorry, LLM models. Okay, it is open source. See, can you see GPT OSS? What is this? 120
Billion.
billion parameters queen. Okay, then deep sea carbon 671 billion, 480 billion, 27 billion. Okay, embedding gamma. For embeddings also you have model. In RAG we will see that. Okay, then 670 billion. Okay, then this billion. Chat GPT is trained on trillion parameters in GPT-5. They have not released, I think, publicly. If I ask Chat GPT, you you are trained on how many parameters?
175 billion parameters.
Okay, see, it is so clever. It has not been publicly disclosed by OpenAI. okay, had 175 billion parameter. 4 is estimated to have 1.28 trillion parameter. Okay, never confirmed this. They want to keep it secret because it is a closed source model. No? It is not open source model. Okay, so see, if it is trillion parameter, obviously model is better. It knows to do. It has tuned for many words. Fine tuning is already there. Knobs is already set. Billion trillions of knobs are set for every different scenarios. Okay, so when it comes to GPT-5 and all, it is trained on trillions. Of course, if they release GPT-6, GPT-7, again trillion parameter, billion won't be less. If it is billion, na, it cannot do much work, much task cannot be achieved. Okay, so this is what it is called as trillion parameter. You can see the news. Okay, if you see news on any AI model, LLM model, it parameters will be definitely mentioned. Parameters nothing but weights and biases. Weights. It has adjusted for knobs are set already. You just pass your input. Attention, embeddings are done, and output is generated. Okay. Since this process is done, it is generating number quickly. Okay, see, if you have pkl file, you know pkl file machine learning, give input, it is giving output because this trained model is there. This is also model only, no, but it is very small descriptive model it is. Okay, here weights and biases already known. Okay, for example, if you want to do prediction for weight for the given height, if you know this is a formula, now y is equals to mx plus c. If you know this m and c, you can, for any weight it can generate this thing. So this is what weights and biases is. Understanding now? So that is stored in .pkl file, .h file, .keras. Okay, many factors, many so these techniques are there. Okay, so these are all trained models. When it is GPT, then huge, it will be in GBs, TBs it will be. Okay, so this is what trained model. I pass my value, it is giving output. Same thing, I'm passing the text, but here transformer architecture, encoder, decoder, attention mechanism, then passing it to feed forward neural network and getting the answer. Same. That's why to learn AI, Gen AI, we need to know about deep learning and ML. Okay, that's why we cannot start Gen AI directly. See, now you know how machine learning works. You know what neural network is. Now you are able to understand. Directly, if I teach this ML to any layman, he will not understand. He will not understand what PKL file is. Dot job leap. Job leap also we used. Okay. So these things has to be made clear. Okay. Now let us see this PPT once again. So what you will learn, I think it is covered. So I think, yeah, LLM foundation is there. Okay, GenAI foundation, Python, though we know. Okay, prompt engineering we will learn little bit. Then chatbots we will generate. So there's conversational chatbots we will build. Drag your insurance thing. We'll do it once again. Okay, with sophisticated thing. We will use complete frameworks. We will use vector databases. We'll use this thing. Embeddings, how to convert into embeddings, those things we'll do, and we'll build a solid project on that. Okay, then AI agents, okay, and deployment of and MCP, very important concept. So this was about this thing. So we have this LLM. Okay, see, LLM is what? It is a type of AI model trained to understand and generate human-like text. So we saw how it exactly works. It is powered through transformer architecture, as I told. Okay, it has something called as encoder and decoder. Okay, I cannot use this. Okay. Okay, this is nice now. Okay, so we will see popular LLMs. Okay, we have GPTs, GPT-5, Llama 2.5, Gemini. Okay, Llama, Facebook's. Okay, Llama is Facebook's. Okay, Gemini is Google's. Okay, DeepSeek, Chinese people's. Okay, then for what it is used? For chatbots, document Q&A, coding to build agents. Okay, these things are used. Now let us see what it is large. What are these parameters I explained already? Why it is told as large? Okay, ChatGPT has 175 billion parameter, while newer models 5 likely exit this. It is in trillions. Okay, more parameter enable better understanding but require significant more computational resource. GPUs, computational resource. Understand? Na? See, these parameters are very important. Okay, if you want to exactly know about LLM, Chat GPT, AI, and all these parameters, we need to have things very clear. Okay, so now let us see workflow how this LLM works. Okay, input text, raw text enters the system for processing. Tokenization, as I told. Okay, text converts to numerical tokens, the embeddings. Okay, then relationship. Who does relationship? Attention mechanism. Okay, find out the relation between the token. Model predicts the next token sequence. Okay, France is a capital in dash, that is what it will. Then converted text goes back to readable text, obviously. Okay, another directly we don't get the raw data generated, it has to refine, and this refinement has to happen. Okay, tokenization. See, tokenization breaks text into smaller units like words, supports characters. This allows LLM to process language efficiently by converting these units into numerical IDs. Okay, splits text into smaller semantic chunks, converts into numerical IDs, that is embeddings, vector embeddings, enables processing of unseen words. Okay, example, chat says has chat GPT splits into G and PD. Okay, this is tokenization. So now let us see. Okay, since we are in the first day of GenAI, we need to see which are the open source and which are the closed source model. Okay, so for open source we have, sorry, closed source we have. Okay, GPT-3, I think these are all closed source model, proprietary LLM. Okay, it is not publicly, I mean, available. Okay, Gemini, then Claude, and all these are all closed source is what we say. These are open source. Llama, Facebook's model is open source. We can easily use it. Google's Gemma is there. These are also open source. But here the parameters are less compared to this. Okay, obviously it's like Mac and Linux. Mac is closed source, Linux is open source, like that. Windows is also closed source. Okay, OpenAI's GPT's OSS. This is open source. We can use it for free. Then we have these Chinese companies. They have made it open source. Okay.
So we made a notebook.
Yeah, yeah, we'll find that. Yeah. Little one content is there. Okay. So we have seen this now already.
Yeah.
Last this we will see generative foundation. Okay, understanding the core concept. So we will understand what AI, ML, DL versus this thing. Okay, we have seen this. Artificial intelligence is a big bubble. Inside this, we get machine learning, deep learning, and see, AI is a science of making machines act smart like humans. What machine learning does? AI that learns patterns from data to make prediction. Linear regression, decision tree, it finds out the pattern. ML one. Deep learning works uses multi-level neural networks to make complex text. Perceptron, this neural network architecture. Generative AI that creates new content. Obviously, we are generating the content. Na? Because of this, we are able to. This is what full AI is. Okay. Real world example. For artificial intelligence, we have Siri, Alexa. Okay. Then for machine learning, we use Netflix recommendation, credit card fraud detection, email spam filter. Machine learning is used even today. Okay. Some emails comes and falls into spam. ML is used. Credit card for recommendation also. Then we have deep learning for face ID, speech to text, image generation. Okay, we use deep learning. Then generative AI is what? ChatGPT, GitHub Copilot, DALI for image generation. Okay. So today we learned a lot of things, I guess. Yeah.
Yeah.
Okay. Let me stop sharing and 1 hour, almost 1.5 hour.